Okay, so in this video, we're going to talk about Newton's second law of motion, but in order to talk about it, we need to remember how Newton's first law of motion said that if no net force acts on an object, then the velocity remains unchanged. Now, what happened, like the second law addresses that what happens when a net force does act on the object. So the second law of motion states that when a net force acts on an object, the acceleration that results is directly proportional to the net force and has a magnitude it's inversely proportional to the mass. The direction of acceleration is the same as the direction of the net force. Now, when looking at this definition, it is important to notice the SI unit of force, which is kilograms times meters per second squared, and it's the same unit that can be described as a Newton. Now, some concept examples. Imagine a soccer player kicks a ball. She causes the ball's velocity to change. In other words, it makes the ball accelerate and cause a change in her velocity. Now, at the same time, if the soccer player doubles the velocity, which means she puts in extra effort and doubles the force, she also doubles the acceleration. Therefore, it can be said that the acceleration is directly proportional to the force. Now, often there are several forces that act at one object at the same time. For example, the wind can act, the friction by the grass can also act upon the ball. Therefore, it is essential to consider and add all these forces to get the net force. The net force is equal to mass times acceleration. The net force is described using the shape that looks like the letter E, but it's actually called the sigma. Now, here are some concepts. So the net external force acting on an object is zero. Which one of the following statements is true? Now, the force it can only be stationary, meaning it doesn't move. And when an object doesn't move, the net forces can either cancel out or means that no force is acting on it at all. So that's a chance. Now, the object can only be traveling with a constant velocity. If it has a constant velocity, then it means it has no acceleration. So if there is no acceleration, there is no net force. Therefore, that can also be a possibility. And C, the object can either be stationary or traveling with a constant velocity. Therefore, that's the answer. Now let's look at another concept question. In case A, an object is moving straight downward with a constant speed of 9.8 meters per second, while in case B, an object is moving straight downward with a constant acceleration of magnitude 8.80 meters per second squared. Which of the following is true? Now it's important to remember that net force is inversely proportional to acceleration, not to speed. Acceleration adds direction, which is a vector. So let's start with A. A non-zero net external force acts on the object in both cases. Now, if a non-zero external force acts on the object on both cases, then it wouldn't be a constant speed. It would be a constant speed, but there wouldn't cause a constant acceleration because nothing would cause it to change speed. It would always stay the same thing. Now, let's look at B. A non-zero net external force acts on the objects in neither case. That can also not be true because if no net external force acts on the object, then the acceleration cannot be caused because there's nothing pushing it forward that will cause it to go faster and faster. Therefore, B is not an. Now let's look at D. A non-zero net external force acts on the object in case B. Because case B is accelerating and it's causing a change in velocity, it is possible that a net external force acts on an object in case B. In case A, since there's no change in velocity, it could be that it just goes on and on forever. Now, also, in something important to remember about Newton's second law is that it's a vector. All forces are vector, therefore they include direction. Now, north and east can be considered as positive, and south of west can be considered as a negative vector. It's important to remember the coordinate plane to divide your forces into x and y components, add them all up together, and you can have your net force. Now you can see from here that the net force can also be described as the net force on the x and the net force on the y. Same for acceleration. You can do acceleration on the x and acceleration on the y. Both the force and acceleration forces are vector quantities. You have to take direction into account when you do your problems, otherwise you're going to get everything wrong. Now, Newton's second law can also be written in an equivalent form as these two equations. Net force on the x equals mass times acceleration on the x. Net force on the y equals mass times acceleration on the y. This is the same and similar to kinematics because, yes, it's all related, your whole physics. So let's look at some concepts. First one. Newton's second law indicates that when a net force acts on an object, it must accelerate. Does this mean that when two or more forces are applied to an object simultaneously, it must accelerate? Now let's look at the little kid. He's a little wimpy kid, and he's being attacked by two bullies from opposite sides. Both bullies are exerting the same type of force, but from opposite sides. Now, if the same type of force is accelerated from opposite side, then the forces will cancel each other out, causing the kid to stay in the middle, being pushed and squished by both bullies, but it will not accelerate. Therefore, the net force would be 0. So no, number 4 is not true. Let's look at another question. All of the following except one cause the acceleration of an object to double. Which one is an exception? Now, for all of these, it is recommended to use numbers and plug it into the formulas. Therefore, it's easier and not as confusing. So let's do letter A. Now, force 1 is equal to 2, force 2 is equal to 3, and my mass is always going to be 1. Now, these numbers you can always make up, and it's pretty easy. Now, if I double my force 1 and I double my force 2, then I can do by the formula that my acceleration will be 10. Now, my original acceleration would have been 5 by doing the formula. So therefore, the acceleration did double, and that cannot be an answer choice. Let's look at B. If the net force acting on the object doubles. So let's begin with net force of 4, a mass of 2, and that will give me an acceleration of 2 meters per second squared. If I double my net force, then my acceleration will be equal to 4 meters per second squared. Therefore, my initial and my final acceleration are doubles of each other. Now let's look at C. Both the net force acting on the object and the mass of the object double. Now let's start with a net force of 4 and a mass of 2. If I double, my initial net force will give me an acceleration of 2 meters per second squared. When I double my net force and double my mass, my acceleration will result in the same acceleration, because you have to remember that the acceleration, the mass, and the net force are inversely proportional. So therefore, C is my answer choice.